Hello. Today we're going to continue our discussion about Pythagorean theorem and even provide you with one more informal proof. Consistently, we know that the Pythagorean theorem is a squared plus b squared equals c squared. And what we really need to make sure we understand is that that's the leg squared plus the leg squared equals the hypotenuse squared. Okay, and so that's the form. One of the main things about the Pythagorean theorem that we must understand is that it comes from using right triangles only. It cannot be used for other types of triangles. And so a lot of times you'll see this used if you're trying to calculate the hypotenuse as a 3, 4, 5 right triangle. And that's a type of Pythagorean triple. And people in construction use that all the time to make sure that their walls are square to their floor or their garage door openings are perfectly perpendicular to one another. And so we'll get into discussing the other uses of the Pythagorean theorem later on. Like I said, what I want to do is really focus in on the proof of the Pythagorean theorem. And so often words I will often use are leg, hypotenuse, square root, right angle, perpendicular, and Pythagorean triples. And as we look at this, you might be wondering exactly how does this relate to the Pythagorean theorem. And again, I'll take and highlight my eventual equation should be a squared plus b squared equals c squared. And so how does this image help me prove that? And so as you're looking at this image, the first thing I would notice is that it's a square. And the area of a square is whatever the side length is times whatever the side length is. So I see this and I see times c would be c squared. And then what's a little bit difficult to sort of pick up is that this distance right here is b. And this part of b is covered up by a. So these little bases of each of the right triangles are A. And so this little section where I don't have the purple marker, that is B minus A. And you can see the B minus A in each of the two spots. I just wanted to make sure we understood exactly how I got B minus A. And so as I look at this larger square, which is C squared, is equal to the sum of its parts. And what I see is this sort of middle square, which is b minus a squared for area. And then I see 4 right triangles. And the area of the triangle is 1/2 base times height. So 4 times 1/2 but base times height, which is really a b. Okay? And so if I look at this and continue my calculations, hopefully it looks familiar to a different type of proof that we've done where c squared is the middle square and then you have the 4 right triangles on the outside. But I'm going to make sure that I understand that this is a perfect square. So my side work would be b minus a times b minus a. And you can use FOIL or you can use the box method, which is b minus a times b minus a. This is b squared. This is minus or negative a times b. This is a negative a times b. And this would be a positive a squared because a negative times a negative is positive. All this review is really fantastic for us because we haven't probably multiplied binomials in a while. So that's b squared minus 2ab plus a squared. So I'm going to fill that in over here. So b squared minus 2ab plus a squared. And then I have to evaluate this. Well, half of 4 is just 2 times AB. Well, if I'm thinking about like terms, I notice that these have the same variables with the same exponents. And so now I have c squared equals b squared plus a squared. The rest is just semantics or syntax. And I know this because of the commutative property of addition. That I could really write that as c squared equals a squared plus b squared, which is my formula. If I further wanted to make sure that it matched the original one, there is the symmetric property of equality, and that allows me to write it in the form you're most familiar with. Okay, and so that's just another like basic proof. You can look it up on the internet if you really want to. The last thing I want to do is look at some of the takeaways or lesson summaries that you really want to guarantee. The first thing I want to make sure we understand is that I'm given a right triangle. The rest of this does not work unless I am working with a right triangle, and that's important to understand. Okay, the next little bit is that sides AC and BC are called legs. So AC and BC, those are legs. AB would be called the hypotenuse. So being able to label your triangle properly is super important as we work with this formula. As you can see, they've labeled it with the letters, and being able to put the right numbers or right values in their respective places is also really important. Okay, and finally, you want to make sure that you understand the formula for Pythagorean theorem. So the Pythagorean theorem is a squared plus b squared equals c squared. Okay, thank you for your time.